Hello, this is the second part of my previous lecture on the interval estimation of population mean. Okay, so look, with an example, I try to clarify this. Here is the table, and this table shows a simple random sample of age of medical insurance holders of a metropolitan city of India. And standard deviation of population is known to us, and that is 6.7. So standard deviation is known, and population and we do not have any idea about the population mean, but the information is given that there are 30 customers that whose have the medical insurance, and their age are given in this table. Okay, so these are the number of customers, and it is from 1 to 30, and these are the ages. Okay, ages of the customers. So this is a simple random sample, and here the mean is 38.7. 38.7, and total of the age of 30 customer is 1160, and mean is 38.7. So mean of this sample is 38.7, and we have information that the population mean is 6.7. On that basis, we try to verify the interval estimation of the population mean. Okay, now from the central limit theorem, it is known to us that the large sample size has a sampling distribution of x bar can be approximated by a normal probability distribution as the size of the sampling distribution of sample mean as large as it is, as large as it is, so it would be a normal probability distribution. This is the central limit theorem. So, the central limit theorem enables us to say that the sampling distribution is approximately normally distributed with mean mu and standard deviation this. Okay, 1.23 is the standard deviation, because this is the sample standard deviation, and this can be calculated on this basis, sigma by root n, and sigma is 6.7 and n is 30. The number of samples is 30, so 6.7, 5.48, and ultimately we get 1.23. Ultimately we get 1.23. So standard normal probability distribution table to make probability statements of the sampling error is this. So sampling error is there. Sampling error. Okay. Sampling error is there. Look at this. This is the sampling mean. This is the mean of the sample. Okay, 38.7. And this is the population mean. This is the population mean. So sampling error is the sample mean minus population mean. We can get the sample mean by simple formula, that is the summation xi by the total number, but it is the point estimation. It is the point estimation. So now this is the sampling error. This is the sampling error. So this is the distribution of sampling error. So this is the distribution of sampling error around population mean. Around population mean, and this distribution is a normal distribution. This distribution is a normal distribution. Now, look, this is the mean, this is the population mean, mu, and the sample mean are distributed around this population mean. And from mean, population mean to this point, population, look at my arrow, the population mean from this population mean to this point is equal to 2.41, is equal to 2.441. Okay, is equal to 2.41, and this is the 2.41, and 2.41 years, and from population mean to this this point is equal to minus 2.41 years. So sampling mean are distributed around the population mean with the standard deviation 2.41 years. With the standard deviation 2.41 years, and this area, this area represents the 95% of the values of a normally distributed random variable. Okay, 95%, because as the normal distributed random variable table, you can find that that 95% of the values of the normally distributed random variable lie within plus minus 1.96 standard deviation of the mean. Okay, 9 point so 1.96 standard deviations of the mean. So 1.96 multiplied with 1.23 is the sample mean, is the sample standard deviation, simple standard deviation 1.23. So we get the value 2.41. We get the value 2.41. As there is a plus minus 1.96, there's a plus minus 2.41. And on that basis, we get this difference. We get this difference, and we get this difference. Okay. 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 Now look at this. This is here the interval estimation of the population mean is this. This is this area. This area is 1 minus alpha. 95% means, what is the 95%? 1 minus alpha is the 95%. 1 minus alpha is the 95%. This area is the 95%. This portion plus this portion is the alpha. If you add this blank space with this blank space, then we get the alpha, the value of alpha. Okay, the value of alpha. So what is the value of alpha? Value of alpha is here is the sampling sample mean, the sample mean around the population mean. When it is more than the standard deviation is 2.41, then this area will be considered. When the standard deviation is more than 2.41, 2 point, when it is more than plus 2.41, then this portion, this blank portion, okay, this blank portion, and when it is it is less than minus 2.41, then this portion. So this portion. So actually this is the 0.025. This is the 0.025. The value of alpha by 2 is equal to 0.025. Okay, alpha by 2. So 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 I hope you have understood the the interval estimation of the population mean. So thank you very much for enjoying this lecture.